Hi everyone, I am Kento Kawasaki, software engineer in the R&D department at Leading Edge. Today, I'm going talking about TextSegmentation.jl, a Julia package for unsupervised text segmentation methods. This is a table of contents. First, I will give an introduction about what text segmentation is and explain the major unsupervised methods. Then, I show you how to use the package and an example of the text segmentation. Finally, I discuss future issues. First, I explain an overview of text segmentation. Text segmentation is a method of dividing text or document according to its topics. When a document describes 3 topics, as in the example here, it is divided into 3 parts by text segmentation. By segmenting the unstructured documents according to topics, the text segmentation contributes to improve the accuracy of various natural language processing tasks. Next, I explain 3 specific text segmentation methods. The first method is TextTiling. TextTiling is a method for finding segment boundaries based on lexical cohesion and similarities between adjacent blocks. For example, if the same word, such as computer or programs, appears in multiple sentences, they are considered to be the same topic. Based on this hypothesis, TextTiling set up a fixed-length window to find the gap score between blocks. The gap score is a cosine similarity between blocks. For example, one block with a blue arrow, the other block is a green arrow. The cosine similarity is calculated based on the words in the sentence. This is the gap score. The gap score is high when the features between blocks are similar, and low when they are different. The value of gap score is considered to be the turning point of the topic. However, since the degree of value depth is relative, the depth score, an indicator of value depth, is calculated to determine the segment boundaries. The segment boundary is considered to be the point that depth score is high. The second is TopicTiling. TopicTiling is an extension of TextTiling that uses the topic ID of words in a sentence to calculate the similarity between blocks. The segment boundary determination method is basically the same as TextTiling, but it uses a topic ID obtained from LDA topic model for feature value. For example, assuming there are 5 topics, each word is converted to the ID of topic to which it is most likely to belong. Setting up a window and comparing the similarity between blocks is the same as described earlier. The third is C99. C99 is a method that uses segmented clustering to determine segment boundaries. It uses the same lexical cohesion and cosine similarity as TextTiling, but in the case of C99, calculating the similarity to all sentences in the document. Then, the similarity between sentences can be determined as shown in the similarity matrix. Next, I create a ranking matrix. The rank is a number of neighboring elements that have a lower similarity with respect to a point in the similarity matrix. And then I create a sum of rank in the matrix, which is the sum of the rank for each segmental region. C99 uses this as the feature value and proceeds with segmentation sequentially, as shown in the figure below right. For example, the first segmentation is done at the segment boundary between 4 and 5, and then segment boundaries are predicted for sentences 1 to 4 and 5 to 9, respectively. Now, I would like to show you a simple example of text segmentation. The package can be used by installing and importing as shown in this slide. This is a sample text. The text is a 12-line document taken from Project Gutenberg, and later on 3 topics. So there are 11 candidates for segment boundaries. In the case of the data, the segment boundary is between rows 4 and 5 and between rows 8 and 9. So the answer segment boundaries can be expressed as follows. A 0 means it is not a segment boundary, and a 1 means it is a segment boundary. Next, I show the code and results for each method. Here is an example of TextTiling and C99. Window size is the size of the block. Num topics is number of the topics in the document. If this value is specified, segment boundaries are determined by the number of num topics, starting with the highest depth score. Input the argument into the segment object and execute segment to obtain the result. The same goes for C99. I got the same result as the correct answer in TextTiling and C99. Here is an example of TopicTiling. In addition to the document to be segmented, TopicTiling requires training document to create the LDA model. The training document should be in the same domain as the document to be segmented. I use LDA model from Jensen, a Python library. The parameters below are the same as described for TextTiling. The result is as follows. The segment boundary between lines 4 and 5 is correctly predicted, but the segment boundary between lines 8 and 9 is shifted forward from the correct answer. I believe the parameters need to be adjusted. Finally, for future issues, I would like to improve the prediction accuracy of segment boundaries, as well as add another unsupervised text segmentation method, and work with other natural language processing libraries. Thank you for listening to my presentation.